Actually, Pandey ma'am called. That is why it has been little delay from my side. Okay, so we'll start with today. Actually, we have to perform the third experiment, but let's quickly revise the second experiment and then we'll go to the third one. So, second experiment was you have to perform. You have to write a program in Scilab for linear and circular convolution using DFT technique. Okay, and already in first practical I have seen many of the students have performed convolution of signal. Okay, 2D convolution they have performed. Okay, so now we have to use the DFT technique. So as per I discussed in the last session that you can write a code, you can take directly values from examples which have solved by you given by Bide ma'am. Okay, or what you can do is simply you can write in generic code where you can able to write input signal sequence and the impulse response sequence, and automatically it will calculate and it will give you the DFT output. Okay, so this way you have to write a code. So simply I will explain the code. I think many of them have tried. Still, I'll give you the flow of the program. That is, first of all, you need to get the value from the user of x of t and h of t. That is input signal and your impulse response, impulse signal. So for that, you will simply use the input command. Then for the convolution and DFT, you require to identify the length of the input signal as well as input signal. Again, you need to use a length command for input signal and for impulse response. Okay, so first is get the input from the user, then find out the length of the input x of t and h of t. Then next is for DFT, it is very important. That is the sequence size should be same. Okay, so for that you need to do the to make the size equal. Okay, you need to use the padding technique, right? So you need to add the zeros. Okay, so for that again you have to write a code. That is the sequence value which you are getting, that is that should be equal to the number of sequence should match. That is x of t is length should be equal to h of t. Okay, after that you need to use the DFT function. Okay, and display the result. Okay, so here what you have to use is DFT function, and you have to first of all do the multiplication. So multiplication when you will do in for 2D DFT, for that time you have to convert the time domain signal into a frequency domain signal. Okay, so initially you have defined that x of t and h of t is given. Okay, from that you have to for multiplication you need to find out y of k. Okay, that will be conversion of time domain into frequency domain. Okay, and then convolution of DFT, that is y of n you need to find out. Okay, so sequence you can take it from your notebook example, and you can put it into the whenever you will execute the program, x of t and h of t value will take it from there, and try to check the output. Okay, so this is for a linear convolution. Similarly, you have to show me the program for circular convolution using DFT technique. Okay, so Devashri, last time you have submitted the program, so I've seen that program. There is no problem in the program, but what happened is the Scilab Cloud today also I tried. It is not displaying any result right now. Okay, so what you have to do is you have to download it Scilab. You need to install it, and then offline you try to run and execute. Okay, so
Ma'am,
huh,
what we want? We want plots or something else.
what?
We want result in a format of numbers like x of k in matrix so and so, or like we can plot that signals.
No, initially you need to get the sequence.
Okay, fine, man, fine.
Hmm? Okay. So once it is done, you have to show me the output. And then about journal writing. So today I talked with HOD ma'am, and I have also checked your first experiment. Some of you submitted the experiments in Word file, so it is neatly written, I think. But Pranav ka dekha tha maine. So he has written everything properly, right from aim, steps, procedure, everything. But madam has clearly instructed that everyone has to write into the notebook. So मैंने मैम को बोला कि बहुत लोगों ने ये किया है, तो can we follow this? But as per HOD ma'am's instruction, she clearly mentioned that you need to write it in the notebook and then take a photo and then upload it. Okay. So once you have completed a second experiment, same way you have to write it in the notebook and then you have to upload. Okay. So just give me 1 minute. Again, I will show you the code, but you have to write it your own. Okay. After that, once you have completed, I will give you the third experiment. Just wait. Hmm. So it is visible to all. So it is somewhat like your MATLAB programming. So, I think till now you have understood the difference between Scilab programming and MATLAB programming. Okay, so I'm not going to discuss that. Also, you know that Scilab is a free version and MATLAB is you need to pay for that. Okay. So first is clear your screen, clear and close. Then you have to take the input sequence, discrete sequence from the user. For that, simply you will use the input command x of t and h of t. You need to ask from the user, or you can directly put the value also. Both ways you can do, but it is advisable that let user enter the sequence, and accordingly it will give you the output. Then n1 is the length. You need to find out the length, okay, because both the length should be same. Okay, and this is the formula to calculate the length. N is equal to n1 plus n2 minus 1. Okay, this is for linear convolution. Okay, so this is very important. Overall length. Okay, then we need to do we need to equal the size. For that, we have to use the padding. Padding means you need to add the extra zeros. So for that, for h comma zeros, 1 comma n minus n2. Okay, this is for h. Okay, for x it is x comma 0, 1 comma n into n minus 1. After that, you need to compute the DFT and IDFT. So for that, first of all, you need to convert your time domain signal into a frequency domain signal. So for that, we are using x of k. So that will be equal to d of t. So this is the function we are using, x comma minus 1. Okay. Similarly, convert h of n into h of k. Now next is multiplication of 2 DFT. So simply multiplication term we will use, and y of k is equal to h of k multiplied by x of k. Then let's look at the linear convolution. For linear convolution, x of n will be equals to d of t of y of k comma 1. Okay, so this is IDFT of y of k inverse, and then display. So the expected output is like this. So initially, when you execute this program, so in the output window, first of all, it will ask for for x of t. So enter the x of t. So here I have taken this example 1 2 3 and 1 2 2 1. But again you have to go to your mm, examples which is given by bd ma'am and just try to match the answer. Okay, and then once you execute you will get this output. Okay, so same way you have to write a code for circular convolution using DFT technique. Okay. So complete the program and show me the output. Both you can do, that is simply you can directly substitute the sequence values into the program or you can ask from user, both the way. एक ऐसे करके दिखा दो, other students show me by taking input from user. Uh, HOD ma'am have also told me that she have already shared one video related to Scilab programming. So she made a video, and that you need to watch. Okay. So after completing this, you can go and watch the video. I think ma'am has explained DFT and inverse IDFT. Okay. So watch that video, and then I will assign the next experiment. Okay, once you have completed the third experiment, second experiment, the next experiment is compute inverse discrete Fourier transformation using FFT algorithm. Okay. Um, if you have completed linear convolution and circular convolution, you can show me the output. Uh, Other student can upload the program as per the given format by HOD ma'am in the Google Classroom. Okay. To just answer your name, Aparna. Aparna is there. Aparna. Hello. Aparna. Bhaskar Vankala is there. Devashri.
Ma'am, Bhaskar is present. Maybe he's having mic issue.
Okay. Hemant. Hemant.
Yes.
Neha. Neha Bachao.
Yes, ma'am.
Omkar Shinde.
Present, ma'am.
Pavan Pawar.
Yes,
Pavan.
ma'am. Hello.
Huh?
Hello, ma'am. Neha is present. Ma'am, mic
Okay.
issue.
Okay. Okay. Pavan Pawar. Poonam Bhosle. Okay. Prajwal Shinde.
Present, ma'am.
Pranav Bade.
Present, ma'am. Present, ma'am.
Pratik Godbole. Pratiksha Kore. Pratiksha. Priyanka Dhakode.
Present, ma'am.
Priyanka Vani.
Present, ma'am.
Rohan. Rohan Thambe. Sagar.
Present, ma'am.
Sandhya.
Present, ma'am.
Saurabh Naikodi.
Present, ma'am.